We built towers to reach the gods. We carved ships to cross endless oceans. For millennia, we looked up at the stars and called them unreachable. Then, in a single human lifetime, we touched them. Every launch is an act of defiance. A controlled explosion pointed at infinity. We send machines into the void to whisper our messages across the solar system. We dream of Mars. We dream of Europa's hidden oceans. We dream of escape. But dreams require infrastructure. And infrastructure requires orbits. Look closer. The void is not empty. We have filled it. 10,000 active satellites circle above you right now. Communication arrays, weather monitors, GPS constellations, Earth observation platforms. Every internet connection, every weather forecast, every navigation app exists because of this orbiting infrastructure. But for every functioning satellite, there are ghosts. Dead spacecraft that exhausted their fuel decades ago. Spent rocket stages tumbling through space, fragmentation debris from collisions and explosions, 130 million pieces of orbital refuse. Most are smaller than your fingernail. All of them are lethal. We have wrapped our planet in a shroud of velocity. Consider this fragment, a fleck of paint that's separated from a Soviet satellite in 1983. It weighs less than a gram. In your hand, it would feel like nothing. Insignificant. But this is not your hand. This is low Earth orbit. Velocity erases the distinction between mass and weapon. At 28,000 kilometers per hour, this paint chip carries the kinetic energy of a 500-pound safe dropped from a skyscraper. When it strikes, it does not bounce. It vaporizes the surface material on contact. The impact creates a crater. The crater ejects more fragments. Each new fragment becomes another projectile in an already crowded firing range. The orbits are not random. They follow laws older than our species. Kepler's equations, Newton's gravity. Every object traces an ellipse, a circle, a path determined by velocity and altitude. But the laws that govern motion also guarantee intersection. Two objects can share the same orbital altitude and never meet for decades, until orbital precession, atmospheric drag, or gravitational perturbations shift one path by a few meters. Then, at a closing speed of 15 kilometers per second, geometry becomes catastrophe. The sky is not a highway. It is a three-dimensional ballistics range where every object is both bullet and target. In 1957, we placed one satellite in orbit, a metal sphere with 4 antennas transmitting a simple radio pulse. The sky accepted it without complaint. 70 years later, we have launched over 16,000 objects. Most are still up there, decaying slowly, tumbling through space with no guidance, no control, no purpose. We called it the space age, but we never planned for the aftermath. We treated orbit like we treated the oceans, infinite, resilient, capable of absorbing whatever we discarded. We were wrong. This is how it starts. Not with intention, but with probability. 2 defunct satellites, launched decades apart, following orbits that have slowly drifted into alignment. Neither has fuel for maneuvering, neither has active collision avoidance. They are corpses, adrift in the current. The closing velocity is 8 kilometers per second. At the moment of contact, the kinetic energy equals 15 tons of TNT. But this is not an explosion. There is no fire in vacuum. What occurs is structural disintegration. Aluminum sheeting tears like tissue paper. Solar panels shatter into 10,000 photovoltaic cells. Batteries rupture, releasing frozen electrolyte. Fuel tanks split, venting hypergolic propellant that crystallizes instantly in the cold. Watch the fragmentation bloom. Each piece inherits the momentum of the parent collision, modified by the direction of the impact. The debris field expands at 500 meters per second, faster than the speed of sound and air. Within minutes, the fragments have dispersed across dozens of kilometers. Within hours, they have spread into a diffuse cloud occupying the entire orbital shell. Each fragment now follows its own independent trajectory, but all remain bound by gravity to roughly the same altitude. This is no longer a collision. This is contamination. An entire orbital band has been seeded with shrapnel. 1 collision becomes 2, 2 become 4, 4 becomes 16. The mathematics are merciless. Each destroyed satellite adds thousands of trackable fragments to the population. Each fragment possesses enough energy to destroy another satellite. The cascade accelerates beyond human intervention. You cannot recall the debris. You cannot sweep it away. You cannot negotiate with physics. This is the Kessler Syndrome. Named for NASA scientist Donald Kessler, who predicted this exact scenario in 1978. Not as speculation, but as inevitability. The collision rate in certain orbital zones would reach a critical threshold where debris generation outpaces atmospheric decay. Beyond that threshold, the process becomes self-sustaining. A chain reaction that transforms orbit from usable space into a forbidden zone. From here, Earth looks unchanged, the same blue sphere that has cradled our entire history. Continents drift, weather systems swirl, ocean currents flow. But above, something fundamental has shifted. The threshold has been crossed. Low Earth orbit, the most accessible region of space, the foundation of our satellite infrastructure, has become a debris field so dense that transit is no longer viable. This is not about damaged satellites. This is about access. Every launch trajectory must pass through this contaminated zone. Every spacecraft attempting to reach higher orbits must run a gauntlet of hypersonic shrapnel. The odds of survival drop below acceptable margins. Launch windows close. Not temporarily, forever. We built this rocket to reach Mars. Engineers worked for a decade on the propulsion system. Scientists designed instruments to search for microbial life in subsurface ice. A crew trained for 18 months, studying geology and survival protocols. The launch is perfect. First stage separation occurs on schedule. Second stage ignition is nominal. Trajectory is precise. Then, at 90 kilometers altitude, a fragment no larger than a bolt, traveling in retrograde orbit, punches through the fuel tank. Liquid hydrogen vents into space. The vehicle loses attitude control. Automated safety systems trigger the abort sequence, but there is no recovery from this altitude at this velocity. The payload, humanity's latest attempt to answer the question, "Are we alone?" burns up on re-entry over the Pacific Ocean. We are no longer explorers. We are inmates, confined by our own detritus. The International Space Station has 6 months of consumables remaining. Resupply missions are grounded indefinitely. Evacuation is impossible. The crew has stopped requesting updates and launch schedules. GPS satellites are failing one by one. The constellation that enabled global navigation, precision agriculture, financial transactions, emergency response is fragmenting. Replacement satellites cannot be launched. The infrastructure we built over 40 years is collapsing in real time, and we are powerless to repair it. Communication satellites blink out, weather monitoring ceases, Earth observation platforms go dark. The modern world was constructed on the assumption that orbit would always be available. That assumption was incorrect. The first year after Cascade begins, the changes are inconvenient. GPS failures force drivers to use paper maps. Weather forecasts become less accurate. International communication experiences delays as ground-based fiber networks become congested. The second year, the consequences deepen. Precision agriculture fails without satellite monitoring and GPS-guided equipment. Crop yields drop 20% globally. Financial markets stagger as high-frequency trading systems lose microsecond timing synchronization. Aircraft navigation reverts to ground-based systems, reducing flight efficiency and increasing fuel consumption. The third year brings systemic collapse. Supply chains optimized for satellite logistics fracture. Emergency response systems lose coordination capability. Climate monitoring gaps prevent accurate disaster prediction. The death toll from a single unexpected hurricane exceeds 50,000 because evacuation orders came too late. 10 billion people, connected by orbital infrastructure, suddenly learning what disconnection costs. She asks her grandmother about the stars. She has learned in school that humans once walked on the moon, that robots explored Mars, that telescopes peered into the hearts of distant galaxies. Her grandmother struggles to explain. How do you tell a child that the sky is closed? That her generation will never know the sensation of weightlessness, the view of Earth from orbit, the possibility of living on another world. The stars are still visible, but they are no longer reachable. We can see them, photograph them, study them with ground-based instruments, but we cannot go to them. This is the psychological wound that no satellite crash or GPS failure can match. The understanding that expansion has ended, that we touched infinity briefly, then retreated, and can never return. We conquered the land, built cities, roads, civilizations across every continent. We conquered the sea, mapped every ocean, established trade routes connecting all nations. We thought we had conquered the sky. 60 years of continuous presence in orbit, thousands of successful missions, a permanent space station, plans for lunar bases and Mars colonies. But the sky does not belong to us. It never did. We were borrowing it, and the terms of that loan included responsibility. Responsibility to manage what we placed there. Responsibility to remove what we abandoned. Responsibility to recognize that space, despite its vastness, is not infinite. We failed that responsibility. This is our monument, not a pyramid or a cathedral or a city, not art or literature or music. Our legacy to future generations is a cage. A ring of metal fragments moving at hypersonic speeds, making transit through low Earth orbit statistically suicidal. The barrier is not solid, not continuous, but it does not need to be. The probability of impact is sufficient deterrent. Insurance companies refuse to underwrite launches. Governments halt their space programs. Private companies disband. The age of spaceflight lasted 68 years, from Sputnik in 1957 to the Cascade event in 2025. Less than a single human lifetime, a brief window in which we were interplanetary. Now we are planetary again, and will remain so for centuries. The debris will eventually fall. Atmospheric drag, solar radiation pressure, gravitational perturbations will gradually reduce orbital altitudes. Fragments will re-enter. The population will decline. In 300 years, low Earth orbit may again be accessible. In 500, the higher orbital shells will clear. But 300 years is longer than the United States has existed as a nation, longer than the Industrial Revolution, longer than modern science itself. The people who created this problem will be dust. Their great generals will still be waiting for the sky to reopen. Entire generations will live and die without ever seeing a human leave the atmosphere. Space exploration will become mythology, something that happened in ancient times, like the construction of the pyramids, remembered but not understood. Garrett Hardin described the tragedy of the commons in 1968. A shared resource, accessible to all, owned by none, will inevitably be exploited beyond sustainability. Each individual actor gains the full benefit of their use, but shares the cost of overuse with everyone. The rational strategy for each individual leads to collective ruin. Orbit is a commons. No nation owns it. International treaties govern its use, but enforcement is minimal. Every satellite operator benefits from launching, but the debris risk is shared by all future operators. The incentive structure is broken. Short-term gain is privatized. Long-term cost is socialized. We knew this. Kessler published his warning in 1978, 47 years before Cascade. Mitigation strategies were proposed: deorbiting protocols, active debris removal, stricter launch licensing. All were deemed too expensive, too complex, too inconvenient, easier to launch first and worry about consequences later. Except later has arrived, and consequences are permanent. We reached for the stars and built a ceiling instead, a barrier made of our own abandoned tools, our own discarded machinery, our own refusal to plan beyond the immediate return on investment. The universe remains vast. Trillions of galaxies, each containing hundreds of billions of stars, planets beyond counting, chemistry and physics and mathematics operating according to laws we have barely begun to understand. All of it still there, still waiting. But we are here, confined not by the limits of technology but by the consequences of carelessness. We did not need faster rockets or better propulsion. We needed foresight. We needed restraint. We needed to recognize that access to space was a privilege, not a right, and privileges can be revoked. The sky has closed, not because we lacked courage to explore it, but because we lacked wisdom to preserve it. And now, for the next 300 years, we learn what it means to be earthbound again, to look up at the stars and know they are unreachable, not because the journey is impossible, but because we blocked our own path. This is the Kessler Syndrome. This is the price of the commons. This is what happens when we forget that escape requires an open door, and some doors, once closed, cannot be reopened.